Have you ever wondered how big companies seem to know what's going to happen next? You know, how they predict sales or demand? Well, I'll tell you, it's not a psychic and it is definitely not magic. It's a really powerful statistical process called time series forecasting. And today, we're going to pull back the curtain and see exactly how it works. Okay, let's get into it. So let's just start with a super practical question. Imagine you're running a company. How on earth do you figure out what your sales are going to look like next year? I mean, this number dictates everything, how much stuff you make, who you hire. You have to have a solid forecast.
But again, this isn't about gazing into some crystal ball. It's more like a detective story. We're going to follow the clues that are hiding in plain sight, right there in the data, and piece them together, step by step, to build a really logical picture of the future.
And for our little investigation today, we've got a real-world case file. We're going to be digging into 15 years of data from a company called ELEQUIP. Our mission? To forecast their monthly new orders. This is exactly the kind of puzzle that data scientists and statisticians solve all the time. All right, so every good investigation starts at the beginning. You check the scene. And for us, that means checking our data to see if it's even ready for us to analyze. The very first thing we're looking for is a property called stationarity. Now, the best way to think about this is that stationary data has a stable personality. Its basic character, things like its average value, how much it bounces around, those things don't really change over time. It's consistent. And you can see exactly what I mean right here. Over on the left, that's non-stationary data. See how it's got that clear upward trend? It's wandering all over the place, totally unpredictable. But on the right, you've got stationary data. It's just kind of hovering around a flat central line. That stability, that is the secret sauce we need to build a reliable forecasting model. Okay, so here's our first plot twist. When the statisticians looked at the ELEQUIP data, guess what? It wasn't stationary. It had trends, it was wandering. So what do you do when your main piece of evidence, your data, doesn't have that stable personality we're looking for? Well, you don't give up. You transform it. The most common trick in the book is a process called differencing. Basically, instead of looking at the raw number of orders each month, we look at the change from the previous month. It's kind of like smoothing out a really bumpy road so you can finally see the actual path underneath. For ELEQUIP, this one simple step was all it took to make the data stationary. Okay, our data is prepped, it's stable, it's ready to go. Now it's time to bring in the tools for the job. We need to line up our potential suspects, our models. Now, the main tool we're going to use is something called an ARIMA model. And don't let the name scare you, it's not that complicated. Just think of an ARIMA model as a recipe for the future. And those little numbers you see, the P, D, and Q, they're just telling us how much of each key ingredient from the past we need to mix in to cook up our forecast. So, for our ELEQUIP case, after analyzing the data, the statisticians came up with 4 potential suspects, 4 different ARIMA recipes that look like they might be the best fit. Our job now is to figure out which one of these is the real deal. So, we've got our 4 contenders lined up. How do we pick the winner? Well, we hold a competition. We basically see which model is the least wrong when it tries to predict the past data that we already have. And what we have here is the model scorecard. We've run all 4 models on the historical data, and we're scoring them using something called the sum of squared errors, or SSE. All you need to know is this. SSE is basically a wrongness score. The lower the SSE, the better the model did. And as you can probably see, one of these models is clearly in the lead. And yep, that lowest score is 1805.90. It belongs to the ARIMA 311 model. Looks like we've got ourselves a winner.
So that's it, right? We just pick the lowest score, pack up our things, and we're done. Case closed?
Not so fast. See, in statistics, the lowest error isn't the only thing that matters. We also care a lot about simplicity. The best model is what we call parsimonious. It's as simple as possible while still being accurate. And crucially, every single part of it has to be statistically significant. We have to make sure every ingredient in our recipe is actually doing something. And to check that, we look at something called a p-value. Let's go right back to that recipe analogy. An insignificant parameter, which shows up as a high p-value, is like an ingredient in your recipe that adds absolutely nothing to the final taste. It's just making things more complicated for no reason. A good chef and a good statistician gets rid of any useless ingredients. And here it is, the final twist in our story. That model with the lowest error? Turns out it had 2 of those useless ingredients. But the ARIMA 210 model? Well,
Its error score was just a tiny bit higher, but it was simpler, and every single one of its parts was significant. It struck the perfect balance. That is our true winner.
Okay, we've done all the hard work. We prepped the data, we ran the competition, we picked our champion model. Now finally, we get to do the thing we came here for, predict the future.
And the process from here is actually pretty elegant. We take our winning model, our perfect recipe, we feed it the most recent data we have, and the model just does its thing. It uses all those patterns that learned from the past to calculate the most likely value for the next month. And just like that, boom, we have our forecast.
So that whole process works beautifully for data like ELEQUIP's orders. But what about data that has really predictable, repeating cycles? Like holiday shopping or summer travel. That brings us to a new challenge and a really powerful upgrade to our technique.
I mean, think about airline passengers. You just know there's going to be a huge spike in travel every summer and around the holidays, year after year. For that kind of data, we need a more specialized tool, the Seasonal ARIMA model, or a SARIMA. It's basically our standard ARIMA model, but with an extra piece bolted on that is specifically designed to understand and predict those repeating seasonal patterns.
And the great thing is, the core logic is exactly the same. We still have to make the data stationary, but we just add a new trick called seasonal differencing, where we compare, say, this July to last July. That strips out the big seasonal swings so the model can see the underlying trend. And then it cleverly adds that seasonality back in for the final forecast. It's incredibly powerful.
So, we've just walked through how a logical step-by-step process can take a bunch of old data and spit out a reliable forecast for things like company sales or airline travel. It really makes you wonder, if we can apply this kind of thinking here, what other parts of our world could we start to predict?